Bright Duty. Every student matters.
Hello students, my name is Sanjay Jain. Today we will study probability, right? We will focus our attention more on theoretical probability in class 10th. In class 9th, we studied about experimental probability and we did some of the questions based on that, right? What is the difference between experimental probability and theoretical probability? It is that in experimental probability, you actually perform an experiment and then see the results, right? Let us say you throw a coin 1000 times and then you see what are the number of times it is giving head on the top, right? And then you calculate the empirical probability of getting a head, right? Let us say you throw a coin 1000 times, right? And 455 times you get head and rest of the times you get tail, right? So what will be the probability of getting a head, right? This is empirical interpretation. So empirical probability of getting a head will be 455 divided by 1000, right? But this is not the exact probability, right? This is empirical probability. It depends on the number of times you perform that experiment. If you perform it multiple number of times, let us say you perform it 10,000 number of times, or then you perform it 1 lakh number of times, or you perform it 1 crore number of times. So the results will keep on changing, but you can intuitively feel that the result will come closer to 1 by 2, right? Or it will come closer to half. So if you perform this experiment a large number of times, you will feel that the empirical probability will be 1 by 2, right? Why do you feel so? Because we know that in a coin, what are the possible outcomes? Either it can give head or it can give tail on the top, right? There are only two possible outcomes here, right? So either head will come or tail will come. Now let me introduce another term for you before discussing the theoretical probability: equally likely outcomes. Equally likely, right? What I am saying here is, what is meant by equally likely is that when you toss a coin, right? Before that, let us talk about a fair coin. When I say that I am throwing a coin in this chapter, I mean that I am throwing a fair coin. What does it mean by fair coin? That possibility of coming a head or possibility of a tail coming on the top is equal, right? It is a fair coin. It is not biased. It is symmetric all around, right? Because of its shape or its structure, it is not favoring a particular type of outcome, right? That is a fair coin. And another type of coin can be a biased coin. Let us say I make a coin structurally biased towards a particular outcome, okay? I make it shape such that when you throw it, it is likely to fall in favor of a particular outcome, let us say head or tail. That is a biased coin, right? A fair coin, it is equally likely for the head to come or the tail to come, right? That is a fair coin. And when we discuss the case of throwing a coin in this chapter, we will ignore the possibility of a coin landing on its edge, right? When you throw a coin, it may be possible in certain circumstances that it may land on its edge, right? We will ignore that possibility. We are just saying that when you throw a coin, it will either give you head on top or tail on top, right? So equally likely events are such events where possibility of a particular outcome is as likely as the possibility of other outcome. So I hope this term is clear to you. Now let us look at this theoretical approach to probability. See, experimental interpretation, or you can say empirical interpretation of probability has certain limitations, right? When you want to calculate the probability of failure of a launch of a satellite, right? You cannot keep on launching the satellites and then calculate the empirical probability, right? So an experimental approach or empirical approach has its limitations. So we need to develop a theoretical approach to it. Or let us take another case where you have to calculate the possibility of collapse of a building in case of earthquake, right? You cannot keep on performing that experiment. You wait for enough number of earthquakes to calculate the probability. No, right? So you have to devise certain other methods to calculate such probabilities. So we will introduce theoretical probability. Theoretical probability. In theoretical probability, we see number of possible outcomes and number of favorable outcomes. What I mean by possible outcomes and favorable outcomes is that, let us say you throw a coin. You have got a coin and you throw it once. What are the possible outcomes? Possible outcomes will be either it will give you head on top or it will give you tail on top. So these are the total possible outcomes of throwing a coin once, right? What are the number of favorable outcomes? That will depend on question to question, right? In a question where we need to calculate the probability of getting a head on top, this will be our favorable outcome. Okay. So this was about number of possible outcomes and number of favorable outcomes. So what will be the probability of an event? It will be equal to number of favorable outcomes divided by number of total possible outcomes, right? So this was about theoretical introduction of theoretical probability. I hope these terms are clear to you, right? Now let us discuss about two probabilities, two special events, right? One such event is sure event. Another we will discuss about impossible event. Let us discuss about sure event first. You have seen a die, right? What are the possible outcomes when you roll a die? Either it will give you 1, 2, 3, 4, 5 or 6, right? These are the possible outcomes of rolling a die, right? Now if I ask you, what is the possibility of getting a number less than 7 when you roll a die? You will say, we will surely get a number less than 7, because 1 to 6 are the numbers that are possible outcomes, right? So all these numbers are lesser than 7. So you will say probability of getting a number less than 7 is 1, right? That means you will surely get a number less than 7. So that kind of events are known as sure event. What is the probability of such event? Probability of sure events is equal to 1, right? What is an impossible event? Let us say in the same experiment, when you are rolling a die, I ask you, what is the possibility of getting a number 8, right? You will say it is impossible. Why? Because 1 to 6 are the numbers available on a die. So when you roll a die, it is not possible to get a number 8 on the die, right? So that kind of event is an impossible event. It cannot happen. So probability of such events happening is equal to 0, right? So there are 0% chances that such an event can happen, and these events will happen 100%, right? So sure event is the event that will happen 100%. Impossible events are not going to happen, right? Another thing that we need to take care in this chapter, some of the terms, let me introduce. Elementary events. What is an elementary event? The event having only one outcome. Let us say I ask you probability of getting head on top when I throw a coin once. What is the probability of getting head on the top? This is the question, right? So what, like when you throw a coin, what are the possible outcomes? Either you will get head or tail. Now I ask you about a particular event, that what is the possibility of getting a head, right? So there is only one outcome in this case which is favorable, right, of getting a head. So that kind of events are known as elementary events. So what I mean to say is, when you throw a coin, you will either get head on top or you will get tail on top. So getting a head on top is one elementary event, getting a tail on top is another elementary event, right? And sum of, let us say, probability of getting a head plus probability of getting a tail is equal to 1. Why? Because sum of all these elementary events, sum of probabilities of all these elementary events is going to be equal to 1. Why? Because these are the only two possible things that can happen. Either it can give you head on top or it can give you tail on top. So the total probability or the sum of probabilities of elementary events is equal to 1. Now let us say these are the only two events. Let us say there is an event E and there is an event not E. This is the bar, right? When I place a bar on E, this means not E. This is an event, let us say, getting a head on the top, right? If I do not get a head on top, I will say E bar or not E. So if I define E as getting head on top, right, then E bar will be not getting head on top. Now, you know, when you do not get a head on top, what will you get on top? Tail, right? Or we can say getting tail on top, right? When I am defining these events, I am throwing the coin only once, right? So you will either get a head or a tail. So in this case, when I define an event E as getting head on top, event E bar or not E is not getting a head on top. So if I ask you, what is the probability of event E happening plus probability of event E not happening, what is the probability? See, when you throw a coin once, either you will get head or you won't get a head, right? You will get a tail. So the probability of an event happening plus the probability of that event not happening is going to be equal to 1, right? These are known as complementary events. So probability of an event is equal to probability of 1 minus probability of event not happening, right? If I say the probability of an event is 0. Let us say 45, okay. So what can you say about probability of that event not happening? We can say that it is equal to 1 minus 0.45, that is 0.55, right? And we also studied about sure event where the probability was equal to 1. We studied about impossible event where the probability was equal to 0, right? a probability cannot be greater than 1 or lesser than 0, right? So, probability of an event can be maximum 1, minimum 0, right? It can be equal to 0, it can be equal to 1, yes, but it will always be between 0 and 1, right? So, if somebody says that the probability of an event is 1.2, it is nonsense, right? It doesn't make any sense, okay? So, these were some of the terms that I wanted you to learn. Now, let me tell you about certain things here. Let us talk about tossing a coin, right? When I say a coin, I am talking about a fair coin, right, where the outcomes are equally likely. In this chapter, we will study the events that are equally likely, right? When you toss a coin, let us say once or twice. When you toss a coin once, possible outcomes are 2, head or tail. So, what are the number of possible outcomes? 2, right? When you throw a coin twice, and let us say you need to calculate the number of outcomes. In the first throw, you may get head or tail. In the second throw, you may get head or tail, right? Head or tail. Now, if you want to calculate the number of outcomes, you will calculate like this. Let us say first coin gives you head and second also gives you head. There can be a case where first coin gives you head, second gives you tail. Where first coin gives you tail, second gives you head. Where first coin gives you tail, second also shows you tail. So, these are the possible outcomes in throwing the coin twice. Or if you are throwing 2 coins simultaneously. Let us say you have got a 1 rupee coin and a 2 rupee coin, and you throw these 2 coins simultaneously. So, these are the possible outcomes in that case: head, 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 tail, tail, head, or tail, tail, right? You need to know these outcomes very thoroughly, because if you are asked a question to find the possibility of getting at least 1 head, or to find the possibility or probability of getting 2 heads, you need to know the total possible outcomes. Let me tell you, if you throw a coin thrice or 3 coins, okay, in this case we are going to talk about that if you throw a coin thrice or you throw 3 coins simultaneously, what is the total number of outcomes in that case? You need to understand this logic, that when you throw a coin once, you get head or tail, right? Now, you throw another coin, you will get head or tail. If you throw third coin, you will still get head or tail. But now, if you want to calculate the total number of outcomes, you will have to calculate like this. First coin gives you head, second gives you head, third gives you head. One of the outcomes is this. One of the outcomes can be you get head and head on first and second coin, and third coin gives you tail, right? Then one of the cases can be head, tail, tail, right? Then one of the cases can be you get tail on all the 3 coins, right? These are 4 cases. Now, another case can be tail, head, head. Tail on the first coin, head on second, head on third. Then one of the cases can be tail, tail, head. Tail and tail on first and second coin, and head on third coin. Then one of the cases can be tail, head, tail, and one case can be head, tail, head. right? These are the possible outcomes when you throw 3 coins simultaneously. What is the number? 8 possible outcomes in that case. So in case of throw of a coin, you need to remember that the number of total outcomes will be 2 raised to n, where n is number of throws, right? In a single throw, 2 raised to power 1, 2 outcomes. In throwing 2 coins simultaneously, 2 raised to power 2, 4 outcomes. In 3 coins, 2 raised to power 3, 8 outcomes, right? Why is it happening? Because when you have 3 coins, let us say these are 3 boxes, right? First box can be filled in 2 ways, head or tail. So there are 2 ways, right? So 2 ways and 2 ways. You need to multiply this. So 8 number of outcomes, right? By these boxes, what I mean is, there are 3 places, right? HHH, HHT, these are 3 places. The first place you can fill in 2 ways, H or T. Second place you can fill in 2 ways, H or T. Third place, H or T, right? So there are 2 possibilities for filling a single place, and you need to fill 3 places. So 2 into 2 into 2, 8 total number of cases, right? So you need to memorize this. 2 raised to power n, total number of possible outcomes will be there. So this was about throwing a coin. Now let us talk about rolling a die a bit, right? A die looks like this, right? What are the possible numbers that it can display? This is not the exact die that I am making here. This is just for representational purpose. So what are the possible outcomes? Possible outcomes are that it can show you 1, 2, 3, 4, 5 or 6, right? So these are the possible outcomes. It cannot show you 7, it cannot show you 0, right? It will show you 1, 2, 3, 4, 5 or 6. So what are the total number of outcomes? 6 when you are rolling a single die, right? Rolling 2 dice simultaneously. Let us say you are rolling 2 dice simultaneously. Once you are thorough with this theory part that I am teaching, the questions will just be a cakewalk for you, right? So you listen to this theory part very, very carefully. So when you are rolling 2 dice simultaneously, what are the total possible outcomes in that case? You may get certain number on this die, top of this die, and you may get certain number on top of this die, right? So how will we calculate total number of outcomes? What are the possible outcomes on first die? 1, 2, 3, 4, 5, 6, right? What are the possible outcomes on second die? Same, right? But when I look at these 2 dice simultaneously, what are the possible outcomes? These can be written like this. First die will show 1, second will also show 1. This can be one possible outcome. Second can be first shows 1, second shows 2, first shows 1, second shows 3, first shows 1, second shows 4, and you can keep on going like this, right? This is about when first die shows 1 and second die shows 1, 2, 3, 4, 5 and 6. So then you can write first die shows 1, first die shows 2, second shows 1, first shows 2, second shows 2, first 2, second 3, right? I hope you have got the idea what I am doing here. Then 3, 1, right? So you can keep on going like this. 4, 1, 5, 1 and then 6 1. So you keep on going like this, 6 1, 6 2, 6 3, up to 6 6. So these are the possible outcomes of throwing or rolling 2 dice simultaneously. So what is this number? There are 6 outcomes that I have written in a row and 6 in a column. And you need to take care that 1 2 and 2 1 are 2 different outcomes, right? 1 2 means that 1 is shown on die number 1 and 2 on die number 2, and 2 1 means 2 came on die number 1 and 1 on die number 2. So these two are 2 different outcomes. So what is the total number of outcomes? You can count it manually, or you can say that 6 in a row, 6 in a column. So 6 into 6, 36 outcomes. So when you roll 2 dice simultaneously, you will get total number of 36 outcomes, right? So this was about rolling a die. Let us study about playing cards a bit. I hope you know about playing cards. If you do not know, do not worry. Let me tell you in brief. Playing cards. Right? So playing cards are total 52 in numbers, right? In a deck of cards, you will have 52 cards, which are playing cards, right? I am not talking about jokers and all. So playing cards are 52 in numbers. Out of these can be segregated in 2 colors. One is red, another is black. So these are equally divided in red and black cards. So red are 26, black are also 26, right? Red cards can further be segregated in 2 parts. One looks like this. This is called diamond, right? This is red. Okay. Another card is this. It looks like a heart, and this is also known as heart, right? When talking about black cards, these can also be segregated in 2 parts. And when you segregate it into 2 parts, it is obvious that diamonds will be 13, hearts will be 13 in number. And when we segregate black cards, let me take black color for this, right? These are like this. These look like this. One card looks like this. This is black in color. This is spades, obviously 13 in number. Another card looks like this. This is clubs and 13 in number, right? So this is about playing cards. Okay. There are 4 kinds of cards: diamonds, hearts, spades and clubs. Okay. Each 13 in number. So now these can further be segregated in 2 parts: face cards and numbered cards. Face cards are king, which has K written on it, right? Queen, Q written on it, and Jack, J written on it. These are face cards. What are the numbered cards? Number 1 is ace. So number 1 is known as ace card, and rest of the numbers can be written like this. So there are 10 numbered cards, 3 face cards, right? And in each segment, or let us say we are talking about cards of diamonds, okay? In diamonds, we will have 13 cards in total, 3 face cards, 10 numbered cards. And in numbered cards, we will have 1 ace of diamond, right? So this was about cards, and this is true for these cards also. these cards can also be segregated in face cards and numbered cards. Okay, so if I ask you what are the total number of kings in a deck of cards, you will say 4. Why? Because 1 in diamond, 1 in hearts, 1 in spades, 1 in clubs, right? In each of these you will have 1 king, right? So there are total number of kings 4. What are the total number of aces? 4. What are the total number of red cards? 26. What is the total number of diamond cards? 13. So this is how you will think about these cards, right? I hope now the theory part is clear.